dear student. In this lesson, we're going to learn about the type of roots of quadratic equations. We know that the quadratic formula for a quadratic equation, ax squared plus bx plus c equal to 0, is given as negative b plus minus b squared minus 4ac divided by 2a. And this b squared minus 4ac, we call it discriminant. The discriminant is denoted as d is equal to b squared minus 4ac, and if the value of d is larger than 0, then the quadratic equation have two real roots. If d equal to 0, the quadratic equation have one real root. If d is smaller than 0, then the quadratic equation have no real roots. Now let's look at this quadratic equation. 2x squared plus 5x minus 1 equal to 0. We'd like to see what are the nature of the roots of this quadratic equation. The discriminant b squared minus 4ac is equal to, this is b is 5 squared minus 4, a is 2, and c is negative 1. This is equal to 25 plus 8. This is equal to 33, and 33 is larger than 0. That's why this quadratic equation have two real roots. To verify this, let's use the quadratic formula to find the roots. This is the formula is negative b plus minus square root of b squared minus 4ac over 2a. B is 5, negative 5 plus minus b squared is 5 squared minus 4a is 2, and c is negative 1 over 2a, there is 2. So this is equal to negative 5 plus minus 25 plus 8 over 4. This is equal to negative 5 minus 33 over 4. So we can see here it has two real roots. One is negative 5 plus square root of 33 over 4. Another one is negative 5 minus 33 over 4. So it is confirmed it has two real roots. Now we have this quadratic equation, 5x squared plus 6 equal to 0. Please find out what type of root this quadratic equation has. If you write this quadratic equation in the standard form, it is 5x squared plus 0x plus 6 equal to 0. So the determinant b squared minus 4ac is equal to, b is 0 minus 4, a is 5, and c is 6. This is equal to negative 120. And you can see here the determinant is less than 0, so there is no real root. In this question, we are given kx squared minus 8x plus 8 equal 0, and it has two real and equal root. And and we are asked to find the value of k. Since we are told that it has two real and equal roots, it means it has one real root. When you have one real root, the discriminant is equal to 0, meaning b squared minus 4ac is equal to 0. This is a, b is negative 8, c is 8, so we have negative 8 squared minus 4, a is k, c is 8, is equal to 0. So 64 minus 32k is equal to 0. So 32k is equal to 64 and k is equal to 2. In this example, you are asked to find the range of p. P is a constant. If the equation p plus 3x squared minus 5x plus 2 equal to 0 has no real root. If it has no real root, the discriminant is less than 0. So b squared minus 4ac is less than 0. b is negative 5 squared minus 4. A is b plus 3 and c is positive 2, and this is less than 0, so we have 25 here, and this is 8 p plus 3 less than 0. We have 25 minus 8p, 24 less than 0. So 1 minus 8p is less than 0. So 1 is smaller than 8p, or 8p is bigger than 1. So p is bigger than 1 over 8. So when p is larger than 1 over 8, this quadratic equation have no real roots. In this example, you are asked to find the equation x squared plus b minus qx minus bq equal to 0 has real root for all value of p and q. So we have to prove that the discriminant is bigger than or equal to 0 since it has real root. So the discriminant is b squared minus 4ac equal to b is p minus q, so p minus q squared minus 4a is 1 here, and c is negative pq. So this is equal to p minus q squared plus 4pq, and this is equal to p squared minus 2pq plus q squared plus 4pq, and p squared minus 2pq plus 4pq is positive 2pq plus q squared, and this can be factorized as p plus q squared. Since the square of any numbers is always bigger or equal to 0, we can say that the discriminant is always bigger or equal to 0, and that means this quadratic equation will have real roots for all value of p and q. It is given that the straight line y equal to k minus 3x intersect the curve at y equal to x squared negative minus 5 at two different points. We are asked to find the range of value for k, the range of values of k. So we have two equations here, y equal to k minus 3x, let's label it as 1, and the curve y equal to x squared minus 5, and this one labeled as 2. To find the intersection point, we have to solve these two equations simultaneously. So we can see here y is equal to y, 1 is equal to 2. So we can say k minus 3x equal to x squared minus 5. So we arrange it, it becomes x squared plus 3x minus k minus 5 equal to 0. Yeah, this is a quadratic equation. Since the straight line and the curve meet at two different points, that means this quadratic equation have two real roots. The discriminant b squared minus 4ac is larger than 0. So b here is 3. So 3 squared minus 4. A is 1. And c is minus k minus 5. This is bigger than 0. So we have 9 minus 4 minus k minus 5 bigger than 0. If we multiply it, we get plus 4k plus 20 larger than 0. So this is equal to, so this is 4k plus 29 larger than 0. 4k is larger than negative 29. K is larger than negative 29 over 4. This is equal to negative 7, 1 over 4. So the range of k is larger than negative 7, 1 over 4. Dear student, you can try it yourself. You also find the value of m if the straight line y equal to mx minus 4 is a tangent to the curve y equal to x squared minus 4x plus y. When it is a tangent, the meeting point is only one point. There's only one meeting point. So let's label y equal to m x minus 4 as 1 and y equal to x squared minus 4 x plus 1 as 2. So we solve them simultaneously. 2 is equal to 1. So x squared minus 4x plus 1 equal to mx minus 4. So we have x squared minus 4x plus 1 equal to mx minus 4m. We rearrange this. We have x squared minus 4x minus mx plus 1 plus 4m equal to 0. And x squared is we have minus 4 plus mx plus 1 plus 4m equal to 0. So since the straight line is a tangent to the curve, we know that the discriminant b squared minus 4ac is equal to 0, meaning it's meet at one point only, that is one real roots. They have only one real roots. So b is negative 4 negative m square over here minus 4 a is 1 x square and c is 1 plus 4m equal to 0. So we have 16 plus 8m plus m square minus 4 minus 16m equal to 0. So we arrange this, we will have okay, 16 minus 4 is 12 plus 8m minus 16m, we have negative 8m plus m square equal to 0. So we arrange this, it is m square minus 8m plus 12 equal to 0. And if we factorize this, you should get m here and negative 6, negative 2. Right? Negative 6, negative 2, you have m minus 6, m minus 2 equals 0. So we have m equal to 6 or m equal to 2. Dear student, please find the range of p if the straight line y equal to 2x plus p does not meet the curve y equal to x squared plus 2. If we sketch the curve, it should look like this. Y equal to x squared plus 2, and the straight line is y equal to 2x plus p, and they do not meet. So let's y equal to 2x plus p be 1, and y equal to x squared plus 2 be equation number 2. To find the intersection point, we have to solve them simultaneously. 2 is equal to 1, so x squared plus 2 equal to 2x plus p. So x squared minus 2x plus 2 minus p is equal to 0. And this is our quadratic equation. And since they do not meet, meaning there is no real root to this quadratic equation, have no real roots. So the discriminant d, b squared minus 4ac will be less than 0. So b squared, this is b, will be negative 2 squared minus 4. A is 1, the coefficient of x squared, and c is 2 minus p here. This is less than 0. So we have 4 minus 8 plus 4p is less than 0. So we have 4p minus 4 is less than 0. 4p is less than 4. P is less than 1. So when p is less than 1, p is less than 1, the straight line will not touch the curve.